No problem.
Let me cook up my. Ta-da! Nothing like teaching. Immediately going over to teaching, facilitating, whatever. Like, all right, teach till 3:30, but I'm so ready, right? I'm like 8 minutes early, and you're here to help me. That's awesome. Thank you.
So do you need to test that clicker before I change it back to the?
I can. I mean, if I test it on here, it should.
Okay.
That works. Thank you. Good. Great. I'm live streaming. This is the future, so I had to make sure that works. How far can I go? How far can I go? Not very far.
Do you want it to be on that table?
That was what I was thinking.
Okay.
But that's okay. I'm just testing the situation. Let's see what we got here. Gotta do the screen. Okay. Pretty good.
Hi to you.
Hi.
Lori Bass.
Yes, I remember you. You were so excited about cutting the donut into 2 pieces.
Yes.
I remember.
It's out of my freezer for years until it finally fell apart.
Do you need me to change it back to so that it's on the projector?
We just sure, that would be great. Oh. Yes. Good. Oh. We're so ready. Thank you so much.
No problem.
See you
Yeah.
in 45 minutes or whatever. Okay.
Tomorrow was the day you want to see this guy. He's always speaking very clearly.
How do you feel about gerrymandering? Yeah. Of course, that's the best always. Only thing you're doing that for. Cross.
I would say this is symbolic. Like little computer science. No way.
It's not directly. It's not
Questions after election.
Hey.
Hello.
This is your. You got it. Oh, I'm following you. This is Catherine from my class. Have fun.
Hello. Hello. How many of you are from Pennsylvania? How many of you are from North Carolina? No one? How about Maryland? Oh, great. What's else? Chicagoland. Illinois?
Areas of fun, crazy looking district.
Yeah. Anything that's going to come up in the top. I don't know what else is coming up in the top. Ohio, that's it.
Yeah, I'm from Ohio.
Yeah.
No examples from Ohio.
No examples from Ohio. Whew.
When we do the geometry of the town, it'll be front and center, because oh my god.
You got this.
All right. 5 feet on either
Oh,
side
oh,
of this
how
road.
about-
That's a
how about
township.
Wyoming?
Don't worry about it.
Anyone from Wyoming, North Dakota, any state that has only one district, Rhode Island? Yeah? Vermont? One district? One district. Yes. No gerrymandering in Vermont. Oh, not conventional gerrymandering anyway.
I always do this.
I realized when you said that.
They sit here. I didn't realize that they like.
Hello.
I realized there was one on each side.
Oh, weird. Yes. No, I just meant I'm not, and I'm gonna be like writing into your face. I do this constantly. I've been a lefty my entire life, and somehow I never learned to like it, which is what I'm doing for it. Yeah, no, I'm good. It's fine.
Hey, it's fun. All right. Thanks everyone for coming. I'm hoping as excited about gerrymandering as I am, or at least you will be soon. So I'm going to talk about the mathematics of gerrymandering, and I want to say at the beginning that all of my slides are by Moon Nugent, which is this mathematician here. She's in the metric geometry and gerrymandering group, and she's a professor at Tufts University, and she gives absolutely the best talks about gerrymandering. So I've watched every talk she's given that's on YouTube. I've read all of her papers, and I didn't want to reinvent the wheel by making my own inferior slides, so I used hers. So with that in mind, okay, great. So I owe an intellectual debt to Moon. Okay, so there's 3 parts to districting. What's going on? So there's 3 branches of the United States government: executive, judicial, and legislative. We'll be talking about legislative. There's the Senate and the House of Representatives. The Senate is easy. There's 2 per state. Every state gets 2. But the House, it has a lot. So the number of representatives is roughly proportional to its share of the population. That's an interesting math problem too. If you want to go into that apportionment, it involves the geometric mean of things. And they add up to 435. Okay, so then every 10 years there's a census. So then we figure out how many people are in each state. And that's the number that we use, the census number, and we also know where the people live, like which block they live in. And then we reapportion representatives. So if whatever Florida is growing and whatever Arkansas is decreasing, then maybe one of Arkansas's representatives moves over to Florida. So then what we have to do is redistrict. So for example, Massachusetts is the one I know the best. Massachusetts has 9 representatives. So we have to take the state of Massachusetts and cut it into 9 geographic pieces based on the census, and it depends where the people live. So we have to cut Massachusetts into 9 pieces with equal population based on the census. If somebody didn't send in their census form, we don't count them. And so the weird thing is that officials set the boundary lines for their own elections. This is the problem. So this is why gerrymandering is a problem in the United States, and it isn't a problem in other countries. Other countries have districts for elections. Other countries redraw their lines, but we redraw them often. We redraw them every 10 years, basically, a lot of times, if the population changes, and officials set the boundary lines for their own elections. This obviously creates a conflict of interest. I should mention, I was just speaking about this with someone before, there's a difference between districting and gerrymandering. Districting is drawing lines to separate regions. So, what now? So, you might wonder, why is it called gerrymandering? Well, gerrymandering is drawing those district lines to benefit yourself. So, it comes from Elbridge Gerry and his salamander. So, Elbridge Gerry was a senator from Massachusetts, and he drew this district, which had, 1/9 of the population or whatever back in the day, and this political cartoonist drew it to look like this evil salamander with extra wings and stuff. And so that's the origin of the term gerrymander. Now you know. Boston is right down here somewhere. Okay, now you know. So how do we draw the lines? Can we just draw them anywhere we want? Well, no. Okay, there are a few rules. Not enough rules, but a few. So there are some pseudo-mathematical geometric rules. They each have to have equal population. That is defined. That we can't mess with that. In many states, they have to be reasonably compact. Each state, as you know, this is the United States. It's a bunch of states put together, and so each state often has their own rules. So there's no it's not in the Constitution how the districts have to be drawn. Each state makes their own rules, but lots of states say that the regions have to be reasonably compact, but then they don't define what compact means. And they have to be contiguous. That means they're made of one piece. This isn't necessarily on the books in every state, but it's generally abided by, because if you don't do that, people make fun of your district. This does get it's confusing when there's water involved, right? Like Michigan, or any other thing where you want to draw a boundary across one. Okay, and then there's non-mathematical things. So many states have on the books that you should respect county or city boundaries. In New Hampshire, we don't think too much about our county, but there are some states where people really have an allegiance with their county. Any of you from such a state? Yeah, you know what county you're from, right? That's right. I have to think really hard to think about what county I'm from, but in those states where counties are important, you want to keep people in the same county voting together. And then the same with cities. The idea is that you shouldn't just cut right through a city unless you really have to. Then there's respect for communities of interest. This is written into the rules in a lot of states. If you have a bunch of people who kind of are similar, you're supposed to not break them up if you can avoid it. And then, so those are all, so equal population, that's defined by the Constitution. These middle 4 vary by state. And then there's compliance with the Voting Rights Act. That is a national law. So this is a racial thing, which says that minorities must be able to elect candidates, must have the opportunity to elect candidates of choice. So if you have like 100 people who belong to the same minority together, you don't have to do anything. But if you have 400,000, which is more than half the size of a congressional district, you must, by the Voting Rights Act, draw a district around them that allows them to elect a candidate of choice. So this is important, and this is one of the strongest tools we have for combating gerrymandering. So then there's some other things you might want, like maybe you want proportionality. If it's 60-40 Democrat Republican, maybe you want to have 60% of the regions have Democrats win and 40% Republican. That's not in there. Competitiveness, maybe you don't want landslide elections. That's not in there. Responsiveness, stability, none of that is in there. So these are some things that you might want in your congressional districts, but they're not on the books. So, good. So let's imagine that we have 6 districts. This is just an ideal, just ignoring geography. We have 6 districts, and we have some people, some green leaning people and some blue leaning people. Well, can you see the colors? You can see the colors, good, okay. So if you were green and you were drawing the lines, you could put yourself so that green wins 4 regions, even though you can see, maybe if you take your glasses off, that green has way less than 50% of the population, and yet they've won more than half of these. So the idea is that each of these is a congressional district. The green voters have more than 50% in this district, so they win. So if you were the green and you drew this, this would be considered gerrymandering, the drawing of political boundaries for your own political gain, drawing of district boundaries for your own political gain. And there's a name for this. So the green has gotten an efficient majority, right? And it's called packing and cracking your opponents. So what we've done to the gray is we've packed them. We said, we can't win all of them. Green can't win all of them, sorry. But we're gonna pack them in so that, okay, they get these 2, but they win them by a landslide. And then what's left, we're gonna crack them so that they have really a lot of people in each of these districts, but not quite enough to win. So that's packing and cracking, and you use them together to minimize the political winning of your opponent. Yeah, so people do. Great, so there's that. So theoretically, it's possible to get a seat share, meaning how many districts you win, that's almost double your vote share. You can imagine each of these gets like 50% of the vote plus like 1 vote. So it's essentially 50%, you double your representation. So if you were unconstrained by geography, that's what would happen, but none of our states look like that. So how does it actually work out? So here's Wisconsin. Some of you are from Wisconsin. You said so, yeah. Here's Pennsylvania, and here's North Carolina. I live like here. And so you can see what happened here. In Wisconsin, basically half the voter, in all of these cases, half Democrat, half Republican in terms of popular vote. So half the votes, 63 out of 99 of the state representatives went to Republicans. In Pennsylvania, this is congressional representatives, 13 out of the 18 went to Republicans, even though, again, it's 50-50 popular vote. And in North Carolina, again, half the votes, but the Republicans got 10 out of 13 of the seats. Well, and indeed, the person said they were drawing a map to elect 10 congressional Republicans and 3 Democrats because I do not believe it's possible to draw a map with 11 Republicans and 2 Democrats. So it's not secret. It's not subtle and it's not secret. And it's legal. Okay, so the key point, the effect of this is that out of the 50 states, the Republicans control 32 of the legislatures. They have 32 out of the 50 governors, and they have all 3, so legislature, governor, in 26 out of the 50 states, and Democrats only have 8 trifectas. Oh, so it's that. State legislature, House of Representatives, and governor. So, what should we do? So it wasn't always this way. You might think, oh, the Republicans, they are the bad person forever and ever. But both parties gerrymander whenever they can. So let's see. So what's in a shape? So we're mathematicians, or at least I am, and you're listening to a math talk. So let's talk about shapes. I'm a geometer. I identify as a geometer. So here's an example. This is Tuskegee, Alabama. So this was a Supreme Court case, Gomillion versus Lightfoot in 1960, because the town of Tuskegee redrew its lines in 1957. So before, the town of Tuskegee was defined as this green square. It's probably a mile on each side, or whatever. After, it was this bizarre red polygon. Puzzling. Why would they want such a 28-shaped polygon? It's not even anything special. Well, before, the town of Tuskegee was 79% black, and after, it was 100% white. So they just went along and used their little tiny scalpel and just cut around the white population and said, this is Tuskegee. And then when they had elections in the future, of course, well, you know how the elections went. So this was obviously wrong. And so it was easy for the court to decide. Let's see. So the last thing I'll say about that is that the Voting Rights Act considers effect, not intent. So if you're like, oh, we didn't know it was going to happen, it doesn't matter. It's only the effect that matters. If it disenfranchises people, then it's no good. So it's pretty clear. It's like a no-brainer. This one's pretty obvious, and it was thrown out, and they had to redo it. Okay, so here's a gallery of some ridiculous shapes. This is Pennsylvania 7. Special to me for several reasons. One is that I live here. So it's no, we don't want you, Diana, region. And also it has the best name of all the regions, which is it's called Goofy Kicking Donald Duck. You see it? You see it? Okay. So it winds, so Philadelphia is here. This is a densely packed area. And it makes a narrowly Republican district, that's why it's red. And it's 88% white, and it just cuts right out the black neighborhoods that are over there. Interestingly, it can be disconnected by the removal of a single building in 2 points, this point and that point. Let's see. Let's zoom in. What happens? What is that actually? That is the Brandywine Hospital, and this one is the Creed Seafood and Steaks. Essential to democracy, these buildings. Do not take them out. So that is super bizarre and ridiculous. Yes. What else? Maryland 3. Beautiful region. Blue crabs. So this plan is drawn by Democrats, opposed by everyone, I guess. And it actually pushed out a 10-term Republican incumbent with an influx of Democrat and minority voters. So this is actually a Democratic gerrymander. Democrats do it too, folks. And what? In defending this, he said, we didn't mean for it to look like this. That's just how the numbers worked out. It was very complicated. You wouldn't understand. We really just had to, we don't deviate anything by more than one person. We had to do this to balance population. So finally, let's talk about Illinois. So downtown Chicago is right here. This is a chunk of Illinois. So this one has Pilsen, which is a Mexican-American neighborhood up here, and Humboldt Park, which is Puerto Rican right here, and it's strung together by a thin strip along a highway where nobody lives. So it barely meets the contiguity requirement by putting in a highway. And this guy, Luis Gutierrez, won 13 straight elections, and always had at least 75% of the vote and often ran unopposed. So you might think, packing. They're packing them in. But actually, this was drawn by civil rights advocates to create a community, to create an opportunity for a minority group to elect a candidate of choice. So in just one of them, there weren't enough. I mean, if you divide 75 by 2, you get 37%. And so if they like merged it with some other things, they wouldn't have had enough to elect a Hispanic person, assuming that people just vote along race lines, which isn't true, but let's just assume it for the moment. So they connected it to this other one so that they'd be able to create a district of opportunity. So it was actually, the good guys. So this is accidental packing. They pack themselves. Or, it happens. This is called the earmuffs. Okay, and then there's North Carolina. No one in here from North Carolina, but actually lots of people at this conference. Oh, North Carolina. All right, North Carolina. This is North Carolina. So beautiful region. So this is a notorious region. Lots of Supreme Court bases. So lots of Supreme Court cases looked at shape, but the Supreme Court never threw out districts based on shape. They said, yeah, we agree, it's a bad shape and there's clearly gerrymandering, but we can't create a precedent because your evidence isn't good enough. It's essentially a beauty contest of regions, and we're not going to engage in an endless beauty contest. So this was created after the 1990 census and billed as a Voting Rights Act district. It slices Black population out of 3 cities, Winston-Salem, Greensboro, and Charlotte. It just takes them and puts them all into one region. So there you go. So originally it was a Democratic gerrymander trying to create a district of opportunity, and later it's Republican by packing everyone into the district. Life is hard. Okay, so let's return to my current state of residence, Pennsylvania. So the thing is, there was a good reason for the Supreme Court to say we don't want to engage in beauty contests, because it turns out that shape doesn't really tell you everything that's going on. So this is the notorious plan with Goofy kicking Donald Duck. Here's Donald Duck right here. You can sort of see him, yeah, and here's Goofy. And then the other shapes are also kind of ridiculous. So you can see, I don't know, there's like this hammer-shaped region here and whatever else. There's this one that goes over and grabs Erie, Pennsylvania, but it also is like this kind of ridiculous. You're like, oh, that has a bad shape. But if you look at these three, I don't know, which one has better shapes than others? Which ones are gerrymandered? Which ones aren't gerrymandered? Kind of hard to tell. They all look kind of compact, these regions. But so we're going to need more precise mathematical tools to analyze what's going on in these. That's the dream. See if we can achieve it. So we're going to achieve it with our tool, random walks. You all walked up here. Hope it wasn't random. Great. So here's an example of a random walk. So this is the number line. Suppose you start at 0, and then you flip a coin. And if you get heads, you go to the right. And if you get tails, you go to the left. So you just wander for a while. Boom, 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 boom. You might wonder, where do you end up after a long time? 0. Yeah, well, at least once, yeah. So I taught a discrete math class with gerrymandering, and I gave extra credit to my students for simulating this. So this is what they got. So after, I don't remember how many runs, 10, 100,000? No, a million runs. Something like a quarter of them ended up back at 0, and, you know, decreasing probability. So yeah, most likely after, so this is 10 flips. This is a 1,000 trials of flipping a coin 10 times and figuring out where you land. So if you take 10 steps, where are you likely to be? Well, it's 25% probability you're back at 0, and the others are. How about a million trials of a 100-step random walk? So you would flip a coin 100 times. Where are you likely to end up? So they ran that too. So pretty likely you're in the middle. It's like pretty unlikely that you'd end any further away from 0 than about 40. So if I said I flipped a coin 100 times and I got to 80, I ended up at 80, you'd say, I don't know about that. Yeah. Okay. By the way, you can also do this in higher dimensions. For instance, you can do a random walk on the square grid. Where are you likely to end up? Well, also back at 0. So it turns out that, yeah, you are more likely than not to end up back at 0. Yeah. With this one, you're for sure going to end up at 0 with 100% probability. With 100% probability, you end up back where you started at least once. Here, it's, yeah, you also probably end up back at 0. But why should we restrict ourselves to these simple, basic, boring situations? You could do other things. You could do anything you could imagine. Maybe you're on a dodecahedron and you're here and you just flip a 3-sided coin to decide if you want to jump there, there, or there, right? You could just jump. You could do anything. You could define any kind of thing to random walk on. You could ask, if I start here and I flip my 3-sided coin a bunch of times, where am I likely to end up on my dodecahedron? All right. So you could random walk on anything. Well, we're going to random walk on districting plans. So this, I guess, is a map of the districts. So I was asking if anyone was from Montana, Wyoming, North Dakota, South Dakota, or Vermont, or Rhode Island. One from Vermont. That's good. So those are places where we don't have to worry about gerrymandering. Okay, so here's a hard problem. You give me a districting plan, or maybe the Republicans give me a districting plan, and I have to decide if it's fair. And I'm not allowed to say, your districts are ugly. That's like not good enough. I have to come up with a real good reason. So, okay, how are we gonna do it? So this is a 7x7 grid. This is a toy example. suppose we have a 7x7 grid and we want to divide it into 7 districts consisting of 7 blocks each. That's simpler, but kind of the same idea. Well, there are 158.7 million ways to do that. That'll take a while to think about all of those. And if you have a 9x9 grid, there are this extremely large number of ways. And if you have a 10x10 grid, well, they ran it on a computer for a month, and they haven't updated what the answer is yet. But gosh, that's a hard problem. So you can imagine if you had something even like just Pennsylvania with its 18 congressional districts, or Massachusetts with its 9 congressional districts, they each have to be composed of tiny little census blocks, of which there are like tens of thousands in each state, for a roughly Pennsylvania-sized state. And so just the number of ways to do that is unimaginably big. Oh, how big? Okay. So what we do, instead of enumerating all possible plans, that's a bad idea, that'll take a long time. What we do is we random walk on the space of all plans. So instead of jumping around on a dodecahedron or a grid, we walk around on the space of plans. The space of plans? What do you mean the space of plans? Okay, well what we do is we run a thing that at each step, it just flips the allegiance of one of the border blocks. Do you see how that's happening? And if it disconnects the region, it throws it away and does something else. So this is a way to randomly move around the space of all districting plans. Pretty cool. Great. So that's what it's doing. And we can explore until we've seen billions of plans. And that's much less than, millions of trillions of plans, which is how much you need to do a real one. So billions you can do on your laptop. So for instance, this is the state of Iowa. Each state has different rules for how you should district. Iowa says each district has to be the union of counties. And there are 99 counties. Maybe you can see that they're labeled here. They're pretty simple looking counties. And so we can wander around all possible districting plans for Iowa. So you see how it's working? So Iowa is broken into 4 districts. So it just wanders around and just gives us some idea of the space of possible districting plans. Cool? Cool? So, Pennsylvania. So this is the one that the legislature enacted in 2011 after the 2010 census that has the notorious goofy kicking Donald Duck and all the rest of it. Then it was the state Supreme Court, not the national Supreme Court, but the state Supreme Court said that it was gerrymandered and had to be thrown away, and they needed to get a new one. So the legislature was like, that's fine, we'll make a new one. But it was a Republican legislature. Okay, they would propose this one. And the governor was like, I do not like your plan. And so the governor, Governor Wolf, proposed his own, which is this one. And then it turned out that none of those were good. And so this is a remedial plan. They brought in someone, an impartial person from outside. They're like, you can't do it yourself, so we're gonna have to do it for you. And they did this plan. Okay, so just by looking at them, I don't know, you can't really tell, is it a good plan, is it a bad plan? We gotta do something. So, by the way, yeah, I said that the possibility space is too large to explore. So suppose a computer tried to enumerate all the ways to divide up the 9,000 voting precincts of Pennsylvania into 18 contiguous districts of roughly equal population. Let's just do it. We have a supercomputer. Let's just do it. Well, it would take a long time. At 1 microsecond per districting plan, this would take until the heat death of the universe. So let's do something faster. We don't have enough time for that. I don't. Every moment of my life is precious. I'm gonna random walk. So let's random walk. Let's talk about what this would mean. And so we're not gonna color things as red and blue. We're gonna color them as orange and pink. So here's a 10x10 grid, and we're gonna make 10 districts. This is like an ideal Iowa, where you have 100 towns. They each have equal population, and we gotta make them into 10 districts. Iowa with 10 districts, not 4. So there's 40% orange and 60% pink. So if it was going to be fair, how many should orange win? 4. Okay, maybe orange should win 4 and pink should win 6. Okay, so here's a proposed districting plan, Plan A. If you count how many of each, Orange gets 2, and then there's one tie, so we'll call it a toss-up. We'll say orange gets roughly, on average, 2.5. If we just take the same plan and flip it this way, orange gets 0. Sorry, plus 3 toss-up. So maybe orange gets on average 1.5. There's 3 ties. If we draw the lines without scalpel, we can get our safe or 4 safe orange seats, and then we'd have our 4 orange, 6 pink, just like we wanted. Yay! But if we draw with our super duper scalpel, we can get 6 safe orange seats. So we can turn our 40% vote share into a 60% seat share. Yeah, they're sort of carefully drawn to benefit orange. So let's assess these plans and look at what's going on. So I, which is Moon, got a computer to do runs of 100,000 random alterations of a districting plan. So let's see what happened. So we got a lot of districting plans, ran it on a supercomputer, not a supercomputer, nope, a laptop. So it's actually really light computing to do random walks. So we're happy. So what you do when you do a random walk, on the number line, we started at 0, and then we wandered from 0. You always have to start a random walk somewhere. So when we're going to assess plan B, we're going to start at plan B, and then just random walk from there. So what happened? So in plan B, there were 3 orange toss-ups. So what we ended up is on average 1.5 regions voting for orange. So what happened? On the first run, this was the distribution, second run, and third run. So it's okay. It's not in the middle of the distribution, but it's still in the part that you can see of the distribution. That's good. How about plan D? The one where we took our 40% vote share and turned it into a 60% seat share. That's 6. Here's our 6 votes that we got. Oh. And that was starting with plan D. It's like it started here and it immediately wandered away into more reasonable regions. So this is a way of saying, okay, this plan was reasonable. We can't say whether it's the best plan, but it's a reasonable plan. This plan, not reasonable, because it's in the invisible part of the distribution. So recently, the Pennsylvania governor, this was in February 2018, had Moon study this. So the governor came up with his plan, the legislature had their plan, and they were like, we got to bring in an impartial person. So Governor Wolf today announced that he will enlist a nonpartisan mathematician. Any of you want to volunteer as a nonpartisan mathematician? Yeah, it seems like kind of an oxymoron because everyone has wants. But anyway, he brought in Moon to provide him guidance on evaluating redistricting maps. So here's what she did. Here's a Pennsylvania analysis. So Pennsylvania, as mentioned, has 9,059 precincts. These are each of them. So these are like census blocks. Each district must be a union of census blocks. These are nonpartisan. They're just like approximately 4,000 people in each one, I think. And they're nonpartisan. As you can see, they're smaller in Philadelphia where there's lots of people, you can't even see them. And then out here in the farm country, they're much bigger, but they each have the same number of people. Okay, so we start with some plans. So this is one of the plans. And then we do a random walk for a while. So 2 to the 30th. That's a big number. 2 to the 10th is about 1,000. So I guess that's like 1 billion. Is that right? Okay, great. 1 billion. So we do 1 billion random flips and subject to the constraints drawn from the initial plan. So here's what you do. You go to the people who do the map and they're like, no, like that guy said, oh, we were just balancing population. You say to the map drawers, what were you taking into account? And they say, oh, we wanted to balance population. We didn't want to break up counties any more than we had to. We wanted to use water. I don't know, whatever they use. You put those into the computer. You can feed those into the computer. And then you come up with 1 billion maps that all satisfy the same criteria as the map drawers claim to have used to draw their map. So that would be different in different states because different states have different rules. Here we use Pennsylvania's rules. Okay, so what happened? So we get a local ensemble of maps similar to the original plan. Okay, so how are we going to measure? Let's talk about what we're going to put on our x-axis because for the previous one I put number of representatives, the number of districts that you win on the x-axis. But you don't really know how people are going to vote. So like the fall 2018 midterm elections, people voted in all kinds of weird ways that were unexpected. So let's talk about what we're going to put on the x-axis. So we used, or Moon used things that people have used before. So like the same metrics that people were using, the same measuring tools that people were using before. So one of them is called the mean median score. This means that this is how much less than 50% of the vote share you can get and still get 50% of the representation. So for instance, you could have only 40% of the popular vote, but get 50% of the representation, then you're 10%, you're 0.1 off, difference between 40 and 50. So that's one of the scores that we use. And another is efficiency gap, which measures wasted votes. So if you pack your opponents into a region, then they have lots of wasted votes there. If you crack them, then they have lots of wasted votes there, and you see how many wasted votes one party has versus the other one. Who has more wasted votes? This is another measure of unfairness. And these are what people use. So that's what we'll put on our x-axis. So prior to the sampling approach, this is what people were using only to detect gerrymandering. They were just like, who wastes more votes? Well, then it must be gerrymandered in favor of the other party. That was it. But this is a better metric. Okay, so here's the idea. We have this metric on the bottom. So who cares what the numbers are, but as you go further to the right, it favors Republicans. As you go further to the left, it favors Democrats. So let's start with the TS plan, which is the legislature plan. So let's start with the current plan. So the current plan is the one that was thrown out by the House of Representatives for being bad. So if you start with the current plan, which is out here, and you run a random walk, this is the bell curve that you get. And it's way out here. Republican favoring. Kind of compelling. On the other hand, if we use this other measure called efficiency gap, and you start here with the plan that was in place that we were actually using to elect people since 2011, you get this, okay, non-bell curve distribution. I'm not really sure why, but it's all over here, and the plan is over here. And then the legislature was like, okay, fine, we'll write a new map. And so if you start with that map, here's the distribution. It's outside of the fat part of the distribution for sure. And the same thing over here. If you use this other measure, all the peaks are over there, and it's still outside. And then the governor proposed a plan. If you start with the governor's plan, the Tom Wolf's plan, and you random walk, this is the curve that you get. So interestingly, even though we have a Democratic governor, his plan was still more Republican favoring than the mode of this distribution, but in the fat part. And same thing, comes over here too. So it doesn't really matter what metric you use. Who cares what these mean, except that they are measuring something important. We're outside the distribution. So this was compelling enough evidence that they threw out all of these and brought in a special master to make a remedial plan, which also falls in the fat part of the distribution. Great, mathematicians to the rescue. Should you want to do this in your course, you can go to my website, click on teaching, scroll down, click on discrete mathematics. I made this awesome discrete math textbook. This is just 2 pages of it. And so I wrote all these problems that guide students through discovering basically the things that you have heard over the last, however many minutes. I don't know, 35 minutes. And so like here's the distribution, here's Pennsylvania, and then here's a baby example of districting plans and having a graph of districting plans and wandering around them. I want you all to use this stuff. Gerrymandering is interesting and it has a lot of math in it. So I would like you to use these materials if you like. You can write to me, you can get them. And if you create your own, please send them back. We want to make a box of stuff that people can use to teach in their class. So if you, I applied it to discrete math, but maybe you can see how it would relate to some other class that you teach, and you could create materials and we could put them together. We're going to have a gerrymandering for educators day at Tufts in a couple of weeks. If you're in the area and you're interested, let me know. We're in the process of planning what, we don't know what people want. So if you tell me what you want, we'll put it in and we'll do it. So contact me, tell your friends, come to Tufts. And also, you can go to the Metric Geometry and Gerrymandering group website. They've done some amazing work. Their papers are not math papers. They're like easy to read. They flow. I love them. I read them for fun. I refresh the page to see if they posted a new white paper. It's very exciting. They posted things, anything people ask them to look at. They don't only look at districting. They look at voting rights. So they looked at like Santa Clara County in California was having a voting problem. And also Chicago, just Chicago, for electing representatives was having a voting issue that they want, and so they looked at that, and so they have white papers on these things. Very interesting. So that is all I want to say. Thank you. Question?
That other slide that I'm talking about.
Yeah, this one? Which one? Which one would you like?
The one with your.
This one? Okay. This is just like what, so you know what happens when you scroll down on my website. I have written problem-based curricula for all these courses, and so you can download them. And discrete math is the only one that has gerrymandering in it. But who knows? Maybe you want to teach something else. Want to see the other one too? That was good. Okay. Yeah. Other questions? Okay.
Can you give us any parameters for Monday, July 22nd?
No,
Like
I don't
signing
know.
up, like time, like.
So we're still planning it. I mean, we're gonna have, definitely there are some high school teachers who are coming, who are in the area, who we're already talking to. I'm not sure how Moon found them, but she found them somehow. But probably something like this, like she gave a talk and they came and they were like, we want to teach geometry in our class. What's going to happen? I don't know, what should we do? What would you want in such a day?
I want something comprehensible that I could deliver, say, to geometry students.
Yeah. I mean, I think we're not gonna give lectures all day, because maybe Moon will give a lecture, she's great at it, but I think we'd like give out activities, handouts, like, here, gerrymander this, and then you could do it. And you can say what you wanted, I don't know. So comprehensible things, what did you say?
For geometry students.
geometry.
So we're talking about kids who've not yet had logarithms or pre-calc or. you know.
Sure. Yeah, I don't think you need any of that, right? You don't need that for this talk, right? No logarithms. Exponential notation I could use, but you don't really need it. Okay?
So did you have to be a teacher in the area, or did you have accidentally random walks and end up there?
You can Skype in. I Skyped in last week. I was somewhere else. I Skyped in. Maybe we'll have Skype in. You can random walk in and end up there. Sure. Sure. Question?
What's your URL?
What's my URL for my website?
To find this.
Well, I mean, generally, you can just search for Diana Davis math. And the URL is kind of a pain. It's like, got some parts in it. It's an academic website. I don't have control over the URL. Sorry. Great. Well, if your state is gerrymandered, try to get people to do something about it. The census is coming up. It's important that we do it now. All right, thank you, everyone. Hi. Me.